Welcome back to my channel. In this lecture, we will learn what is feedback and what are the different types of feedback. It is an open loop system. If there is any change in the input, based on that input changes, it will change the output. And in this open loop system, there is no automatic control on this output. If you want to control the output, manually you have to control the input. This type of system is called open loop system. So in open loop system, there is no direct connection from output to input. That is, feedback is missing. Here in this open loop system, if you provide a connection from output to input, then it becomes a closed loop system. If there is a connection exists from output to input, then that system is called closed loop system. Here, a fraction of output is fed back to the input. This is called closed loop system. And this part is called feedback part. So the fraction of output which is fed back to the input is called feedback. Let us see the example for open loop and closed loop system. For open loop system, switch and the lamp connection done. Here, by controlling the position of switch, you can control the lamp. This is an open loop system. And for closed loop system, you can take air conditioner. If you set any temperature, even though the room temperature varies, automatically the air conditioner corrects its temperature to the set value. So there is a feedback system within this air conditioner. All the automatic system has a feedback. So feedback, that is the fraction of output which is fed back to the input. There is two types of feedback. One is positive feedback, another one is negative feedback. In positive feedback, where feedback signal is in phase with the input signal, so normally it is added with the input signal. And for negative feedback, your feedback signal is 180 degree out of phase with the input signal, and normally it opposes the input signal. So in positive feedback, your output gets increasing, and in negative feedback, it will decreasing. So first, let us see positive feedback. Here, in positive feedback, the output is fed back to the non-inverting terminal of the operational amplifier, and the feedback signal is in phase with the input signal. So next, let us check the effect of positive feedback in operational amplifier. Here I am taking one closed loop system. Here A is the amplification factor of the operational amplifier and beta is the feedback factor. I am applying input 10 to this system and the amplification factor is 2. Then the output is 20. So it amplifies the input 2 times. 2 times it amplifies the input. So 2 into 10 you get 20 at the output. This is without feedback. Now we are providing feedback with a feedback factor 10%. 10% that is equal to 0.1. So 10% of this 20 volt is 2. So the feedback is 2, right? So 10 percentage of our output voltage is 20. So 10% of 20 is 2. That 2 is fed back to the input. It is a positive feedback, so it gets added with the input. Now we get 12 here. Now the input is 12. So next it is amplified by the operational amplifier. You get the output 24. By providing positive feedback, the output increases. Without feedback, the output is 20. With the feedback, the output is 24. Next, let us check the gain. Gain is output by input. So without feedback, output is 20 and input is 10. So gain 20 by 10 is equal to 2. With feedback, the output is 24 and the input is 10. So 24 by 10, that is 2.4. So the gain increases. So in positive feedback, where output increases, Similarly, the gain also increases. It is called regenerative feedback. But due to this increasing nature, it may lead to oscillation. Normally, this positive feedback is preferred in oscillator circuit, not an amplifier circuit. Next, negative feedback. In negative feedback, the feedback signal is applied at the inverting terminal of the operational amplifier, and the feedback signal is 180-degree out of phase with the input signal. Normally, it opposes the input signal. Thereby, it decreases the output voltage. Let us check that. Here I am taking one closed loop system with the negative feedback. Here I am applying 10 volt. Amplification factor, that is gain of the operational amplifier, is 2. Then the output is 20. Without feedback, the output is 20. Now we are providing feedback with a feedback factor of 10%, that is 0.1. Then the 10% of this output voltage is, the meaning is the 10% of this output voltage is fed back to the input. So the 10% of 20 is 2. So 2 is fed back to input. It opposes the input. So it gets subtracted from the input. So now the input is 10 minus 2, 8, which is applied at the operational amplifier. It gets amplified and the output is 16. 8 into 2, 16. So before feedback, we have 20. Now the output is reduced to 16. So the negative feedback reduces the output voltage. So next, let us check the gain. Before feedback, the output is 20, input is 10, so the gain is 2. After feedback, output 16, input is 10, so 1.6. So in negative feedback, the gain decreases. So in negative feedback, the output decreases, so only it is called degenerative feedback. Normally, it stabilizes the output. That is, it maintains the output within the desired level. It is used in amplifier circuit.